To review for the final, we're going to go over some kinematics problems. The three main equations of kinematics are x of t equals x sub 0 plus vt plus 0.5 at squared, v of t equals v sub 0 plus at, and v of t squared equals v sub 0 squared plus 2a times the quantity of x of t minus x sub 0. Here's a sample kinematics problem. A car travels at 18 meters per second. If the driver slams the brakes and the car decelerates at a rate of 6 meters per second squared, how far will the car travel from the time the brakes are applied to the time the car stops? To solve this problem, we first solve for the time it takes for the car to decelerate to not moving at all, having zero velocity. Then, once we have that time, which is 3 seconds, we plug in that time into the equation for displacement, and we get 27 meters. This means that the car will travel 27 meters from the time the brakes are applied to the time it stops. Here's a second problem. Hayden and Matthew are riding around the neighborhood on their scooters. Hayden is at rest when Matthew passes him moving at a constant speed of 0.37 meters per second. After 1.8 seconds, Hayden decides to chase after Matthew, accelerating at 0.91 meters per second squared. How much time must Hayden accelerate before he is side by side with Matthew? To solve this problem, you first find the distance Matthew traveled before Hayden starts moving. In this case, 0.66 meters. Then you just set their displacements equal to each other, and you solve the equation for t. When you do all the steps listed here, you'll end up with a quadratic equation, which you can use the quadratic formula to factor, or you can use the quadratic formula to solve, and you get t equals 1.683 seconds. I hope you enjoyed these review problems on kinematics, and I hope they were helpful. Thank you.